Welcome to the first in a series of videos demonstrating SSH, SFTP, and CRON. The intended audience here is people who are interested in learning a little bit about Linux, a little bit about secure file transfer, and job scheduling. We're going to talk first about SSH and key exchanges. SSH is an acronym for Secure Shell. Shell being a term referring to basically a command line environment on a server typically. The use of keys with SSH allow automatic logins. As we know, logging into a computer typically requires a password along with a user ID, and keys, exchanging keys between two computers is a way to eliminate that necessity of entering a user ID and password every time you log in. We'll also talk about SFTP, which is an acronym for Secure File Transfer Protocol. It gives us a way to securely move files between different computers. The files themselves are not encrypted before they're delivered. A lot of times you'll see various tools like PGP encryption using SFTP eliminates the need to first encrypt the file and then decrypt it on the receiving end. And one of the handy features of SFTP is that you can use batch files to facilitate automation. Lastly, we'll talk about CRON, which is a Linux-specific scheduling utility, and it's very handy, pretty flexible. There are comparable tools in the Windows environment. To set the stage, we're going to actually have three small Linux computers representing a client, a vendor, and us. These are actually Raspberry Pis. They're very small and very inexpensive Linux-based computers. If you're interested in learning more about Linux or computing in general, learning to code, these are a great environment. They're available for about $35. And we're going to set up an environment where we have three different computers, one representing the client, vendor, and us. Like I said, we will transfer a file from a client to us. We will send a file from us to a vendor. We will send a file from the vendor back to us, and we'll send a file back to the client as well. So let's get started. Here we are. I'm logged on to a terminal application running on my laptop. You can see at the top here I've got three separate tabs. They are labeled Our Server, the SFTP Vendor, and the SFTP Customer servers. You can see that we've got different IP addresses for each of these. I'm going to log into Our Server and enter the password, which is fine. Okay, so I'm connected to Our Server at this point. I've already logged on to the other client computer, which is color-coded here for clarity with a green text on a black background. The vendor environment is amber text on a black background. Our computer here in the center is black text on a white background. I'll be toggling back and forth between those. I made them different colors simply so we could differentiate between exactly where we were. So the scenario here is we're going to want to send files to and from our server to the client and the vendor. Basically, we'll get a file from the client, we'll send one to the vendor, and we'll get one back from the vendor, and then send one to the client. So if I'm here on our computer and I want to connect to the client computer, I would simply issue the SSH command. I would tell it where I want to go and who I want to be when I get there. So I'm going to say I want to become or log on as the client user at the client user IP address, which is that address. Now here's the sticky point. I'm prompted immediately for a password. I have an account, I'm set up, it's okay for me to log in, but I have to type in the password. And you can see now that I'm logged onto the client computer. If I toggle over to the client computer environment and see who's logged in. I can see, in fact, that I've logged in twice, once in this terminal session, and I have another user logged in from this other IP address, the one ending in .30, which is this user right here. Okay, so there's no doubt that I'm logged into a different computer, and that's exactly what we wanted to do. The problem is, like I said, we had to enter a password at the time we logged in. So I'm going to log off from here, and I'm back on our server, back on our computer. The way to log in without using a password when you're using the SSH protocol is to provide an SSH key to the destination computer, so that you can so the protocol SSH can basically authenticate who you are, because it's got because it has the key on the other end. So the first step here is, let's take a look in the SSH directory and see what we've got. We have a couple of files, authorized keys and known hosts. We won't talk about those today, but I want to generate a key because this is a brand new computer and I haven't generated my SSH keys. So there's a simple command that we're going to issue called SSH keygen. Using this command, we'll generate SSH keys. It's actually two files that work in tandem to do this authentication during login. Now if we look back in this directory again, we see now we have two new files, the one beginning with ID underscore. One is a private key, and the one ending with .pub is the public key. This is the one that we're going to send off to both the client and the vendor computer, so that we can log on directly without having to be prompted for a password. To do this, we're going to send that key, and I'm flipping through commands I've used recently. This is the command to copy that public ID file to a different computer. And you'll notice I'm going to send this to the client user account at the IP address ending in .31. I'll be prompted for my password one last time, hopefully. And let's try that again. That's the problem with passwords. So now I've sent my key to the other computer. I'm still on our server, so I can test that. I can confirm that by using the SSH command to log on to the client computer again. And you'll notice I did not get prompted for the password, and I'm logged back on to the client computer. So I'm going to repeat that process, or repeat the process of sending the file I'm back on our computer. I'm going to repeat that process of sending the file to the vendor account at the other computer. I don't have to regenerate the keys. I'm going to use the same key for all my contacts, which keeps it simple. And I will copy that ID to the vendor user account at the other IP address. And I'll type in the password, and I'm done. And I'm still on our server, so I'll see if I can log into the vendor user account without keying in a password. All right, so that's pretty much all there is to it. I had an account on both computers provided by the client and the vendor to me. I generated a key pair, and I sent the public portion of that key pair to both of the computers that I want to log on to remotely. And that is basically all there is to it, to get this done. And at this point, we'll end here and move on to the next video, which will be a separate standalone video talking about the secure file transfer protocol itself and how to optimize that.